CVE 2024-3094. When you look at this CVE ID, you may think I'm going to talk about a vulnerability, but that is not the case. I'm going to talk about a supply chain attack. Yes, this CVE ID is given to a supply chain attack, a sophisticated supply chain attack that happened in recent times. And since I said it is sophisticated, it has some low level stuffs in it. So in this video, I'll try to cover as much information as possible, though I couldn't understand all of the stuffs. I'll just tell you briefly what are all the things that you need to know. Without further ado, let me bring you to the relevant blog. Now you are looking at the blog published in JFrog, and you can see the title. It is CVE 2024-3094 XZ backdoor, all you need to know. And as they mentioned, they gave plenty of details in this blog. I found this blog very informative. That's why I brought this blog to you. And the backdoor name is they just call it as XZ backdoor because the backdoor injected into the package XZ. It is actually an open source utility and being utilized by multiple applications like OpenSSH. That is why we call this as one of the complicated, one of the highly impacted attack in recent times. So let me bring you through this specific blog. On March 29th, that is when this specific attack disclosed. It was reported that malicious code enabling unauthorized remote SSH access has been detected within XZ utils. A widely used package present in major Linux distributions. Since it is being used by OpenSSH, it is also being utilized by all the major Linux distributions. And here is the GitHub project link. And when I try to open this GitHub project, it is temporarily been disabled since it was, it was hijacked, the library hijacked. And fortunately, the malicious code was discovered quickly by OSS community, which is nothing but open source software developers community. And it literally shook that community because you cannot become an open source software developer that easily. You need to gain that credibility. You need to gain that reputation before becoming that OSS and to be a part of open source developer community. And that attacker took his time to gain that credibility. It was actually a well orchestrated attack. He took almost 4 years time to just establish this attack and managed to infect only 2 of the most recent versions of package. He took that much time and only managed to infect these 2 versions of this XZ util package. And both these 2 versions are not in a stable package. Instead, it was in an unstable package, I suppose, which were released within the past month. Stable versions of the most Linux distributions were not affected. As I said, it was not affecting the stable distributions. If you installed any unstable distributions of a specific Linux version, then you may assume you are infected. And the sophisticated malicious payload that came with affected version of XZ utils ran in the same process as OpenSSH server. As I said, the XZ util is incorporated by the OpenSSH service when it runs, and this XZ util is a part of that specific service. And it actually modified the decryption routines in the OpenSSH server. That's what it did in order to allow specific remote attackers and to send the arbitrary payloads through SSH, which will be executed before the authentication step, effectively hijacking the entire victim machine. So this is what happens when that specific backdoor took place in your machine. So it actually allows a specific attacker to send arbitrary payloads. That is very important. Actually, that specific attacker has the private key and the public key is blended with that specific XZ util. So only that specific attacker can send certain commands to that whatever that package installed on the victim's machine. And this supply chain attack came as a shock for OSS community. As I said, it is not easy to become an OSS developer, but that hacker managed to become, and he finally exploited a couple of highly utilized packages. And XZ utils was considered trusted and scrutinized project. The attacker built up credible reputation. This is what I recently mentioned, and we are going to understand who are all affected by this and how to detect this and how to remediate this. So these are all the steps we are going to learn, and who are all affected with this vulnerability. And here you can see the major Linux distributions and its affected branches and also the affected packages. And here is the remediation steps given by this specific distribution. Well, you may refer this. I'm not going to go through every distribution in detail, but you can just look at this. I'll give this link in the description so you can go through this specific stuff. And scrolling further, how to detect this vulnerability, which is very simple. By using your string utility, you can spot this, and here are the commands to use. So you need to find the versions. It should be either 560 or 561. So here they used a regular expression. So by using this regular expression with a single command, you can manage to find this specific vulnerability. If you find an outcome like this, then you can think you are vulnerable. You are having that affected package in your system. That is the case. And how to remediate this? First of all, since it is incorporated with the SSH service, you need to stop that service, and maybe you can try upgrading or downgrading that XZ utility. Okay, because it is affecting only two versions, 560 and 561. The versions lesser than this, the versions greater than 561 are not affected. So you can just try to move this package to any other unaffected version, and that is the recommended stuff. And here this JFrog came up with a script that detects this specific vulnerability. And here is the technical analysis, a very important point. Since it is a low level stuff, I'll try to bring whatever the stuff I can. The end goal of malicious backdoor introduced by CVE is to inject code into OpenSSH server that runs on the victim's machine and allow specific remote attackers who owns the private key to send arbitrary payloads through SSH, which will be executed before the authentication step, effectively hijacking the entire victim machine. Well, this is the stuff. The backdoor payload is still under analysis, but based on preliminary analysis, it seems payload is highly sophisticated. And you can see the stuff. The payload gets injected into OpenSSH server since liblzma that contains the malicious code is a dependency in a certain builds of OpenSSH. And I said XZ utility is infected. And within the XZ utility, this specific file contains the malicious code, and the payload hooks the RSA public decrypt function. When you call this specific function, the malicious payload is executed in the infected version. And that's what they're trying to say, I suppose. A function originally used for validating RSA signature, the malicious hook code examined the RSA public modulus passed inside the RSA struct. Note that the modulus is completely controlled by connecting the SSH client. The malicious hook code decrypts the N value with hard-coded decryption key. The decrypted data is checked for the validity using the ED448 elliptic curve signing algorithm. So here are some low-level cryptographic stuff, and it actually tried to validate the key. The user who give the command, if they have valid private key, then only the specific recipient take the command. Otherwise, it will reject that command and it will try to behave normally. Okay, it will try to act as a benign service. So that is a sophisticated thing involved in this specific attack. And if the data is invalid, that's what I just mentioned. Anyway, the original implementation of RSA public decrypt is resumed. Otherwise, it will just hook the malicious code. The sophisticated nature of this attack and use of highly future-proof crypto algorithms. So since it is using highly sophisticated cryptographic algorithms, the attack may be orchestrated by some nation-state attackers, nationwide attackers. And the timeline of the attack. If you see this timeline of the attack, you might get wonder because as I said, it is actually a well orchestrated attack. The attacker took his time to orchestrate it. You can see the timeline. It began in 2021. That is when the hacker's account created on GitHub. Then he gradually gained that credibility. by interacting with the community, by contributing some code to the community, he actually gained that credibility. Later, eventually he managed to just inject his malicious code in that main open source repository. In 2022, February 6, he submits the first legitimate commit. It is actually a legitimate commit. To maintain his credibility, he was committing the legitimate stuffs at the beginning. Then later, he gradually starts laying the base to his attack. And in 2023, June 17, a series of changes were made to XZ-utils, possibly setting the ground for the attack. This is when he started laying the base for the attack. And here are the commit details. And he introduced ifunc implementation to XZ-util. I'm not sure what it exactly does, but he introduced it because just to dodge the code changes that he makes in future. And in 2023, July 8th, he opens a pull request in OSS Fuzz, a project that performs fuzz testing on XZ and many other OSS projects. The PR disables ifunc fuzzing, which effectively prevents OSS Fuzz from finding the malicious changes done in XZ. So he already made a change. He already introduced this stuff so that whenever he makes any changes, it will not be notified to the specific, maybe the specific community. And he also added one git ignore, I suppose. He added a git ignore file, and he tried to avoid certain files to get pushed to the repository. And these are the couple of files which contains the malicious code was added in the repository. Actually, it was added in February 23rd, 2024. And then on March 2029, eventually it was actually the specific supply chain attack has been disclosed by a researcher called Andres Freund. So this is when it happened, and you can see some important stuffs here. Once the malicious code is included in the repository, it was pulled by Fedora. Fedora was used that code, and when he made the second change, when he updated the version from 5.6.0 to 5.6.1, it was again pulled by Fedora. So as I said, these are the open source utility pulled by various Linux distributions, and was only XZ affected by this malicious actor. And actually, once they found this supply chain attack, they started tracking the changes made by this specific user, rogue user. And they found another package is potentially affected with this, by this user. And they gave some details about that as well. OSS Fuzz. In early 2023, he changed the primary email address. Yeah, here is the stuff. This is what I changed. This is what I said. He actually switched the email address of this specific repository owner with his email address, so that whenever there is a code change, whenever there is a change in a code, the notification or there is a vulnerability reported, that specific email address added will be getting the notification. So the attacker made sure any notification regarding of this vulnerability detection shouldn't be sent to the repository owner. Instead, it should be redirected to himself. So he made sure this stuff brilliantly by using this, and the rest of the stuffs related to the some JFrog thing. And here is the original OpenWall notification, which was actually sent on 29th around 8:51. Here is the researcher who found this specific vulnerability, and he has reported this to this. And backdoor in upstream XZ lib LZMA leading to SSH server compromise. Well, these are this is the detailed analysis done by this researcher, and here are some low-level stuffs given to this. Hopefully, this is the stuff. They are piping some shell. They are trying to execute the system command eventually. So by modifying some stuff, they are just trying to do. And affected system attached DFS security inverse first after configure, where it decides whether to modify the build process or to inject the code. Okay, with the backend lib LZMA installed, logins via SSH become lot slower. This is an important thing I wanted to mention. And when the compromised library is installed in your system, if you try to log in with SSH, you may experience some significant delay. And you can find that, you can make sure that by using time command in front of SSH. So that is what they tried to do. So they found a significant delay because before executing this command, it was trying to execute the command that is sent by the attacker, or it is trying to reach the attacker. So that is why it took its time. And initially starting SSH outside of system, okay, here it is. OpenSSH doesn't directly use lib LZMA. However, Debian and several other distributions patch OpenSSH to support systemd notification, and libsystemd does depend on LZMA. Okay, this is an important stuff. OpenSSH is not directly using this affected library. Instead, some Linux distributions patch OpenSSH to support systemd notification, and that specific systemd notification is depending upon that malicious library. So that is how this specific OpenSSH became vulnerable. Initially starting SSHD out of systemd didn't show the slowdown despite the backdoor briefly getting invoked. This appears to be part of some countermeasures to make analysis harder. Okay, observed requirements for the exploit. Term environment variable is not set. argv needs to be, so these are all the prerequisites to trigger the exploit, to do the exploitation. And scrolling down further, there are a lot of low level stuff. I was just trying to understand this stuff, but I couldn't understand many of the things. But however, when I was reading through these paragraphs, I was able to understand few stuffs at a higher level. I'm just trying to bring those stuffs to you. If you want to understand some low level stuff, I'll give this link to you in the description, so you can go and check that. Backdoor initially intercepts execution by replacing the hifunc resolvers. So here are some functions, and which calls this specific function injected into code. Okay, and I'm scrolling down. What are all the other things that I need to know? Impact on SSHD. The prior section explains RSA public decrypt. This is the function compromised. Please, PLT was redirected to point to the backdoor code. Yes, whenever you calling this function, it will be pointing to the malicious function, malicious code block. If the authorized user give the command. The trace I was analyzing indeed shows during the public key login of the exploit code that is invoked. All right. So these are all the stuffs given in the main blog. So let me go and read through this Sleeping Computer blog. Red Hat warns of backdoor in XC tools used by most Linux distros. Today, Red Hat warned users immediately. Not only Red Hat, all the major distributions, all the major Linux distributions send advisory about this specific cyber attack. No version of Red Hat Enterprise Linux are affected. We have reports and evidence of injections successfully building in XC56X versions built from Debian Unstable, and other distributions may also be affected. All right. Here there is an advisory by Debian. Linux admins can check which version of exe utils. So there is another bash script given just to check whether your exe utility is infected or not. And here is a post where this researcher mentioned some information about this. I think this specific bash script that is used to find this impacted code, the malicious code. The above script will perform strings command. Yes, the same stuff. The Microsoft engineer, he only reported this. We already seen. I haven't analyzed the code precisely. Even the researcher who found this attack agreed that he is not a complete reverse engineer, but even though he is not a reverse engineer, he still managed to do an awesome job. The same stuff, we just referred it. Interesting how this backdoor can lead to an SSHD compromise. OpenSSH doesn't directly use libLZMA. However, Debian and several other distributions patch OpenSSH to support systemd notification, and lib systemd does depend on LZMA. I just mentioned it. OpenSSH directly not using that affected package. Instead, Debian and other several distributions patch OpenSSH to support systemd notification. While applying that patch depends on that affected package. That is how it became vulnerable. And that's it in this Bleeping Computer blog. Anything else do I need to mention? And here you can see the blog published by CASA. And this security researcher Lockness-KO, he has actually came up with a honeypot that contains the vulnerable XC package. And I just tried deploying that vulnerable honeypot, and I tried to play with that, and I couldn't find some interesting stuff. Maybe I couldn't understand what exactly happened there. However, I'll just try to bring that same stuff to you as well. And here is my VM. And before that, let me bring this to you. The Red Hat, you can see they gave the criticality score as 10, because all you need to do is to install that Debian system and run the SSH server. When it initiated, it automatically establishes backdoor to the attacker, and that's why they gave the score 10 to this vulnerability. However, NVIDIA is not yet defined the score, since they are doing the assessment in progress. And you can see the description, embedded malicious code. This is not actual vulnerability. It is actually a malicious code discovered in a popular open source package. Well, it's a supply chain attack, simply. All right. Now, let me open this backdoor and show the stuff. I already pulled the GitHub package, not this one, this GitHub honeypot package to my VM. And now I'll try to run this Docker stuff, and let's see what exactly going to happen. Here I am, opened that specific path and downloaded that vulnerable honeypot. Opening it, all I need to do is to run the Docker compose. Let me do that. Docker compose run. All I need to do is to run the Docker compose. What exactly happened? Did I miss something? Let me open that package. Up, I guess, not run, up. Now I initiated the honeypot. The honeypot is running. I can confirm the same by using the typical Docker command. The command is nothing but sudo docker ps, and here you can see I started running the vulnerable honeypot. Yeah, it is actually running on port 22. I can see ss-luntp just to show that SSH that is listening on port 2022. You can see it is listening on port 22. Yeah, so this is the stuff. I'll just try to log in this, but before that I need to know the IP address of this specific container, right? So let's see how I can grab this IP address. Sudo docker container, I guess, container. What is the command? I think I need to get information about this. Let me check for the command, Docker command. Command to get the IP address of Docker container. Inspect. Yes, it is. Inspect and the container ID. We have this container ID with us, and here is the IP address. So this is the IP address. On this IP address only this specific SSH server is running. I'm able to ping this, and let me run nmap and check whether the SSH is open or not. -p 22. It say it says it is closed. However, it is vulnerable, I guess. When I try to access this, before it closed the connection, I think it will do something. So let's try to check that. I actually tried interacting with this Docker container, exec -it. I think the container ID I need to give here. What is the container ID? The container ID is nothing but this one. Container ID bash maybe. Yeah, I got the root shell of the container, and here actually I tried starting that SSH service, systems CTL list, I guess. No, it is not recognized command. Anyway, I'll system CTL status of SSH maybe, SSHD. No, so this is what actually happening. When I was trying to do this, I couldn't do, unfortunately. Yeah, it gave me this alert. I might be doing something wrong. Maybe if I'm doing anything wrong, you may feel free to let me know. So this is the stuff. I couldn't enable this. However, whenever I try to connect this SSH some random username and 172.18, I guess. I forgot that. Yeah, I forgot the IP. 18.0.2. SSH some random username 172.18.0.2. When I give this, the connection refused. But here, if you see, there is a folder logs created. In logs, if I try opening that logs file, I can see what are all the commands that I executed. It is attaching one probe. It executed bash, including the system calls. It displays everything. You can look at this. Some weird stuff happened here. And these are all the commands executed by me. Some system calls. I'm not sure why this Firefox is being called. Maybe I opened Firefox, right? It might trigger during that time. But it checks some MD5 hashes. What else? Some weird stuffs are happening in the backend. You can see. AWK handler HTTP read link. Yeah, a lot of weird things happening. So this is what the steps described by the honeypot maker. Logs are stored in the .logs file. Currently monitoring, including the BP trace monitoring, exec VE calls, syscalls, which where the parent process is SSHD. So when I try triggering that SSH command, it try to record everything in a log file. And also I found a pcap file. So let's try to explore that as well. Why do we need to leave that? I'm opening it with Wireshark. Yeah, here is the file. I found bunch of MDNS, multicast DNS request, and some ICMP stuff. I'll try to follow the UDP stream. Do I get anything interesting? My host name. Apart from that, I can see a couple of names, domain names. I'm not sure what sort of domain names they are. So these are the things I couldn't understand. Maybe if you understand, please feel free to let me know in the comment section. You can also reach me on LinkedIn, Twitter. Yeah, so this is what. Yeah, so this is what I wanted to showcase. I wanted to share. It has been the talk of the town for past 2 days. So that is why I thought to brought this topic to you. It's been a long time since I made this kind of attack description describing a cyber attack or describing a vulnerability. So yeah, a complete feel after a long time. Yeah, hopefully you enjoyed it. I'll catch you next time with another exciting one. If you really like this video, do consider doing all those YouTube stuff, YouTube algorithms, like, comment, subscribe. You can feel free to share this video among your friends so that people can view this video and they can recognize. And yeah, I'll catch you next time with another exciting one. Until then, I'll see you later. Signing off. Cheers, and I love you all. Thank you so much. Bye.